Now in this class we will be looking at some numericals which use the Charles law. So Charles law, as we have already studied, relates the volume and the temperature of gases when their mass and their pressure are not changed at all. Okay, and what it says is that the ratio of volume to temperature, it remains constant. So V1 by T1 is equal to V2 by T2. So not very difficult, very simple. And this was the original experiment which was done by Charles, and we have studied this in the previous classes. So the relationship between the volume and the temperature actually is linear. It is always linear. So now with that understanding, that basic understanding, let us move on to solving the numericals. So here is a very simple numerical. There is a plastic bag which is laid on windowsill. Okay, so it is put on the window where the sunlight is actually coming in. Now the temperature is increasing from 20 degrees Celsius to 30 degrees Celsius. Notice when I told you before that this temperature 20 degrees Celsius and 30 degrees Celsius, we actually have to convert it into Kelvin. Okay, so it is very important that we convert all the temperatures to Kelvin when we are applying the Charles law. Very important. Or for that matter, any kind of gas law we are applying, we have to make sure that the temperatures are always in Kelvin. And it is very simple to convert it into Kelvin. We just add to 273. So this will become 293 Kelvin, and this will become 303 Kelvin. Okay, right here we can do it very quickly. Now if the original volume is 100 centimeter cube, okay, so unit is incorrect, we can fix it right here. Now we have been asked to find the final volume. Of course the peanuts would not really increase in volume, that we can ignore. So only the gas, the air which is present in that plastic bag would actually increase. Its volume would actually increase. And so we can directly use the Charles law here. V1 by T1 is equal to V2 by T2. So that is the original law. We'll directly use that. That implies that our V1, the volume 1 is 100 and our T1 is 293. That is equal to V2 we don't really know, that is what we have to find out, and T2 we know is 303. So if I solve this further, I can see that V2 is 303 into 100 divided by 293. If you compute this, this would come out to be 103. Okay, around 103.4 centimeter cube. Okay, so you can always do this calculations approximately, and we have a separate class on doing the approximate calculations to solve your objective problems quickly. But if you use those techniques, you should be able to arrive at a reasonably comfortable answer, reasonably accurate answer relatively quickly. Okay, so now let's move on to the second problem. Now here the problem is given of a weather balloon. So the weather balloon is filled with a hydrogen gas. So it is filled with gas. Of course we have filled it at the normal air level. So it is filled with gas at 1 atmosphere. So that is what the pressure of the gas is. And the temperature is also given. The temperature is given as 25 degrees Celsius. Now the diameter has been given, and the final volume is also given, or original volume is also given. Okay, so the diameter is given and the volume is given. What we have been asked, that if the weather balloon is left in the atmosphere, then of course it will go up. At that high altitude, the pressure would decrease and so would the temperature. What have we been asked is that to find the volume of the balloon when it is reached that height where the pressure is half of its sea level value, which means that it has become 0.5 atmosphere, and the temperature has reached minus 40 degrees Celsius. The very first thing that we need to do is that we need to convert all these temperatures to Kelvin. So what we need to do is that we need to add 273 plus 25. So this will become 298. Okay, so this is a value which you should remember, it comes often. And then this minus 40, we have to remove 40 from here. So this will become 233. Okay, Kelvin. That is the first thing we need to do. Now the law that we have to apply is a combination of Charles law and Boyle's law. Okay, so this is the Charles law on the top and the Boyle's law right here. So this is the Boyle's law here and the Charles law is right here. Okay, so both the laws are combined, okay, in this equation. So that is the law we are going to use. It is known as combined gas equation as well. Okay, and we have studied this in a separate class. Okay, so if we combine these two, our original pressure is actually 1, so very simple, into volume is 298. Okay, so we don't notice that we don't really have to convert all the units to SI units. And why is that? Because we are only interested in the ratios. Okay, so we are equating both the sides. We just have to make sure that when we are doing this equating, both the sides have same units. As long as that is true, we don't have to convert the units at all. Okay, so this is a proportion or a ratio proportion kind of a question. Then of course the temperature initially is 298, and this is equal to P2, so pressure has become half, into V2, which we don't really know. We have to really find that out. And then the volume has become 233. Now all the values are known except for V2, so we can really solve this equation, and we can find the value of V2 as 22100. Okay, so the V1, sorry, this was supposed to be V1. I have written temperature here. That is actually incorrect. This should have been 14100. Okay, so this comes from here. This is the original volume, and this is the final volume which will come, and this is equal to 22100 liters. Now if we assume that our this particular balloon is actually spherical, if it's spherical, that's what we are going to assume, then we can say that this volume of that sphere is actually equal to this much liter. Okay, now if you solve this, you will get an answer of R which will be equal to 1.74 meters. Okay, and you can solve it yourself. This is what the value of R would come out to be. So the thing here is that we are assuming that the balloon is actually spherical. Okay, so that is what we have assumed, which is a reasonable approximation. It is not totally unreasonable. What we have been asked to find is actually the diameter of the balloon. If you find the diameter, it will be twice this value. So this will become 377, this will become 4, and 4 plus 4, 8, and that would be your answer. Okay, so very simply we are able to solve the questions. Very important kind of questions based on gas laws. Very simple, very scoring. Here our values were slightly more complicated, so you have to use the approximations as you go along and solve these questions. You need to do lot of practice. So go to DoorstepTutor.com and start practicing now. Okay, without practice you will not be able to solve the numericals. You will get stuck in the examination, which we don't really want. Thank you.